Alright, welcome to my brief overview of the TouchTracker app and tool that I've been working on. If I sound a little congested or super unenthusiastic, it's probably because I have a bit of a fever and a cough at the moment, so not feeling 100%. But anyway, that aside, I will try and do my best to demonstrate what I've been doing and the reasons for it, and without going into too much technical detail, because I think at another time for the technical crowd, I will do like a proper deep dive into the design and implementation. But for now, I'm just going to briefly overview the purpose and what it's based on and how it works and the data we get from this touch tracking software. So currently a lot of this research on like decisions or A and B choices or priming and those kind of things can be done with mouse tracking and using the data from that to look for things like inherent biases or other things. It's pretty useful and has been shown to like give some interesting results that are worth taking into consideration. But what I wanted to do is go a bit closer to the person that's performing the experiment, the subject, because I feel like the mouse it acts as a proxy for the actual movements rather than a kind of direct working with something on a touch screen. And of course, there's also the problem that a lot of younger users will be very familiar with touchscreen interfaces, but not so much with mouse. So it may be less intuitive to use a mouse for them than a touchscreen. So this hopefully is something that can provide a tool to make it easier to get people that may not be familiar with using a mouse or unable to or whatever to participate in these experiments and actually get some rich data. So obviously, before making any claims about the accuracy or comparative accuracy of this data compared to mouse tracking, I want to get some data from different participants using this experiment that you can see here, this candle, candy experiment. And I think this one is one of the kind of very well-known ones in the field that uses mouse tracking. And basically what I've done is, for a first stage, implement this experiment as the kind of demonstration and core element of my touch tracking app. So let me demonstrate how this works. So I've designed it using Flutter, which allows it to be compiled for Android devices, iOS devices, and website as well. So I'll demonstrate the Android one and the web. The Android device I'm going to demonstrate on is an emulator. So the sound sometimes gets a little bit like crackly, but I've got the exact same tablet, the Nexus 10 here, which I'm going to be using for the experiment, and that sound is not an issue there. So I'll just quickly demo this. Here we have the TouchTracker start page, so you enter your participant ID as with most things. Let's just call it demo, and then we start the experiment.
Ruler.
So first you get the audio prompt, which is telling the participant which stimuli or which target they have to find. And this end experiment button here is not there on a production release. As you can see here, this is a debug release because it's just for testing. But when you download that APK that I've the Android app or use the web version, that's not there. This is just what I've been using for testing because I don't want to record a video of me doing the entire trial, all of the trials, because it takes too long. So yeah, let's just do that.
Clown.
Then you get the next one.
Clown.
Right, so this is going to be one of the phonological pair. So this
Clown.
is the third prime.
Cloud.
And then the phonological competitor.
Pear. Strawberry. Strawberry. strawberry,
This is a motor prime
rocket,
and a motor non-competitor.
cat,
And this would be just one
truck,
of the control ones. This is another phonological prime.
truck, truck, track,
Well, anyway, you get the point. This will continue on until the end of experiment. So I've replicated the exact design of the Spivey et al. Experiment, but it is completely customizable. So of course you can change the stimuli. You can change how many of the motor groups or motor conditions are displayed, how many of the phonological conditions are displayed, how many controls there are, and how many primes there are for each of the conditions, the motor and the phono. So once the participants completed their experiment, they this data is saved already to the device, but you can just download it or like share it using the Android interface. So then I'll quickly demo the web one as well, and then we'll get to the data. So on my GitHub, there's a link to the live preview, and you'll see you can run this full screen or not, of course, and then this
trophy,
exactly the same.
cloud, cloud,
So both for the web and the mobile versions or the tablet versions, they're implemented in the exact same way. But that's something I might have to take into consideration because I want to do mouse tracking and touch tracking. So obviously with any touch device, you can use the touch tracking. When it's on the web version, it might be interesting to implement a way to see if they're using a mouse or touch input, and then deal with it. And it's slightly different because obviously for touch tracking, there's certain things that you don't have with a mouse. Like there's never a point where the mouse just disappears. But if they lift their finger off, of course, you move your hand away from the surface, then it'll stop. But I've accounted for that in a way that it just stays where they left it, and then you can continue on.
Cloud.
So maybe if there's like a big break in the time, you can assume that's what's happened, or like use it as like a fixation or something. But the way the analysis happens depends on whether this is something that happens frequently, because during all my trials, it happened a few times, and when I was getting my kids to test it out as well, it happened occasionally, but not enough that it was something that would add a whole lot of noise to the experiment. So I'll have to think about how to deal with that if it's necessary later on. So as you can see, it's exactly the same, and then you can download the data from the web. It doesn't actually save anywhere until you download it on the web version because there's no server for this. But now I will show you what the data part of it looks like. So the idea is that this is 100% compatible with like OpenSesame Mousetrap generated data, and then can be used with the Mousetrap R package to import the data and analyze the movements. So I have some examples in here. The TT one here is like a full trial. So this is one I did, the complete experiment. And I'll give you a look at the data here. So it's a bit messy because obviously I'm trying to show you a massive CSV with all this tracking data. But the important things to note is it shows like the response times. It tracks each mouse movement with the X and Y positions, and also the time stamps along with those. So they're the kind of required things for Mousetrap. But in addition, I did include device data. So if you run it from a tablet or a web browser, it doesn't matter. You will still get the screen details, like the dots per inch, the width and height, which can then be used to like compare data across different devices and different tasks. I think that will prove useful. For me, not so much, because I'm going to be using the same device for all of the experiment. But if you wanted to publish this as a web experiment that people could participate in, for example, it might be nice to be able to compare them across different devices. So if you have one person that's got a huge screen, like in terms of pixels, and it takes them longer time to move the mouse, you want to be able to like account for that. So all those details are there as well. So that's kind of what the data looks like. Obviously it stores like the conditions, which stimuli were presented, all that kind of stuff. And finally, I think it's worth just showing some of the outputs from the analysis that you can get. So this is using the normal, like I've got an example R script here, and you're using the normal like mousetrap package in R. You can just generate like a plot of the response time. So you can see here, I didn't plot the control condition for this one because it was just me testing it, but for my full experiment, you can actually see that my results were somewhat similar to the original experiments, in that the phonological trial response time was actually slightly lower than the mean motor primed trials. And finally, I just think it's worth showing that animation you can generate like with Mousetrap, which gives all of the data that's been kind of normalized a bit and starting at the same point and ending at the same corner. So you can see all the different movements from each of the trials, and just to give you an idea of like that each individual trial data is tracked, and you can compare them however you want and group them however you want. Yeah, so there's a lot more to this in terms of like the implementation, but it's quite robust as it is now, and I'm at the stage of actually gathering some experimental data to start comparing to the original study, and hopefully if I get like at least similar or maybe better or whatever results, then it can be a tool that can be used for all kinds of experiments like this in future that would use mouse tracking. It might be an option to consider using touch tracking instead, because even a lot of like laptops have touch screens these days as well. So yeah, it might be something to worth consider. Anyway, that's where I'm at, and hopefully this was somewhat useful. Thanks for listening.